Okay, so we've been solving some practice problems with exponents and logarithms. So here's some word problems we can go back to where we did our exponential models with interest, population, and decay. So this problem here says, assuming a half-life of 5,728 years, how long would it take for 3 grams of carbon-14 to decay to 1 gram? So let's remember our formula. I believe it was A of t, this is a decay problem, equals A sub 0 times A raised to the t. So let's see what we can figure out here. We have a half-life of 5,728 years. So it doesn't matter what we want to start with. We can start with 1 and end with 1/2 to try and figure out this rate, this little a. And our t would be 5,728 years. So more or less we got 0.5 equals a to the 5,728. And how we did this before was we had to take a root of both sides to find this little a. The 5,728 root. So we're not going to find anything too super here. But what we will get, if we round it to 4 places, let's see here. Should be about close to 1 as we can get. 0.9999. Okay. So our exponential function for this would be a of t equals. Now we're actually going to worry about the starting amount, which would be which would be 3. 3 times 0.9999 raised to the t. So we're going to start with 3, and we want to know how long it would take to end up with 1. So we have our end value, our starting value, our rate. So the reason this is different than the ones we did when we first started the exponential functions is we're looking for a t. Before we would plug a t in. We found the little a before, but now we're are looking for the t. So this will be 1/3, because I got to get rid of this 3 in front, equals 0.9999 raised to the t. So how do I get that t out? I convert it to a logarithm. So t equals log base 0.9999 of 1/3, which won't go in my calculator very nicely. So I will need a change of base formula. So that'll be log of 1/3 over the log of 0.9999. Now this would definitely come out a lot better if we use the exact value, like the 5,728th root of 1/2. But that seems a little ridiculous. So let's see here. Log of 1/3. And we'll divide that by the log of 0.9999. So I don't know how much we're going to be off here, but the calculator is telling me about 10,986 years. So based off how we did this, we could expect to be off somewhat. Let's see. That's a good bit off from the book. So I'm imagining they probably did not round this over here. So let's try another one. This one here has to deal with money, so it must be an interest problem. Wayne has $12,500 in a high interest savings account at 3.6% annual interest compounded monthly. How long will it take for the investment to grow to $15,000? So let's see what all we know here. Well, the formula we're looking for is A of t for the ending amount equals P times parentheses 1 plus R over N raised to the N times T. So let's see what we've got here. We've got an ending amount of 15,000. That's how much we want to end with. We have a starting amount, 12,500. We have a rate of 3.66%, which will change to 0.0366. We have an N of monthly, so that's 12. And the T is the thing we do not know. So let's plug everything in and see what happens. So 15,000 equals 12,500 times 1 plus 0.0366 over 12 raised to the 12t. So eventually we're going to change this thing to a logarithm, but let's see what we got. 15,000 divided by 12,500 is nice enough. That's 1.2. Then this guy over here we're going to have to change in a moment, but I'll just write it down so you don't get too lost yet. So let's figure out what this thing in parentheses is. The thing in parentheses looks to be 1.00305. And since that was very nice, I'm just going to keep it as is. So I'm going to have 1.2 equals 1.00305 raised to the 12t. So I want to get to that t. So logarithm 12t equals log base 1.00305 of 1.2. Again, that's not base 10, not base e. So we'll change it with a change of base. So log of 1.2 over log of 1.003. Sorry, 1.00305. So 12t is going to be approximately, if I put that thing in my calculator, so 12t is going to be about 59.8687. That'll be years. Well, let's leave that off. Let's go ahead and divide by the 12. That's the part that matters. So divide by 12, and that is close enough to 5 to round off. So in the essence of this problem, it's saying that it would take about 5 years to make that happen. Which I guess you could do some guessing and checking to getting there, but we did a little bit more accurate method, and we could pin it down if we needed to. Right. Thank you.